Today's topic, we're going to look at the lowest common multiple and the highest common factor. In order to work out the lowest common multiple or the highest common factor, we need to first concentrate on the topic of the product of primes. If we work out the product of primes, we should be able to calculate the lowest common multiple, otherwise known as the LCM, or the highest common factor, known as the HCF. The product of primes is broken down into two words. The word product means to multiply. So there's going to be some multiplication in here. And then primes, as in a prime number. And a prime number is a number that can be divisible by 1 and itself, simply saying it's got two factors. So an example of the smallest prime number that we can think of is 2, because 2 can be divided by 1, which is 2, and by itself. So 2 divided by 2 is 1. So it's got two factors. It's also the most special number because it is the only even prime number. After 2, if you come across any other even number, they're not prime. So after 2, we've got 3. 3 can be divisible by 1 and itself, no other number. We can't have 4 because it's even, so we move to 5. 5 can be divisible by 1 and itself. We've got then 6, which is even, so we move to 7. So 7 can be divisible by 1 and itself. And then 9 is the most common number that people put. But they think that because it goes up in odd numbers, 3, 5, 7, so the next one should be 9. What we need to remember is 9 can be divisible by 1 and itself, but it can also be divisible by another number, which is 3. So if it's divisible by 3, therefore 9 cannot be a prime number. After 9, when we look at it, the next odd number is 11. Then 13, 15. 15 can be divisible by 1 and itself, but it can also be divisible by 3 and 5, which means it's got more than two factors. So therefore, 15 cannot be a prime number. After 15, we've got 17, 19, and 21. 21 can be divisible by, say, 3, 7. Soon as you find a number that's not 1 and itself, okay, therefore it is not prime. We can cross it off the list. So in order to do product of primes before we start this topic, I'm going to pick two numbers here. So let's pick 36 and I'll pick 75 for now. We're going to break the 36 down into product of primes. So we're thinking of two numbers that multiply together to make 36. So in this case, 6 times 6 makes 36. Now, because the 6's are not prime, we can break the 6 down even further. So to make 6, we can say 2 times 3. Notice I'm not using 1 because 1 goes into every number. So that's why I haven't used that. So we've got 2 and 3. Now, because 2 is a prime number, which we showed on the list, we can block it off. We block it off by circling it. And the 3 is also prime, so we block it off by circling it, which means we can't go any further than that. Those are our prime numbers. I've then got the 6 here. I can use a 2 again, and the 3, and I can block it off. Therefore, if I put these circles together, what I've worked out, I've got 2 times 2 times 3 times 3. Just checking it, I've got 2 times 2 times 3 times 3. Now, I have a habit of doing it from the smallest number to the biggest number. And there's a reason for that, which I'll kind of show you later. We can break the 75 down as well. So 5 times 15 makes 75. Now, from the 5 and the 15, 5 is prime, so I can already block that. I can't go any further than that. The 15 can be broken down, so we don't circle the 15 because it can be broken down, with 3 and a 5. 3 is a prime, so I block it. 5 is a prime, so I block it. How do I write these numbers out? Again, from smallest to biggest, 3 times 5 times 5. So that's what our product of primes are. Now, I'm just going to rewrite those again in a different color. So I'll use red. So 36 is equal to 2 times 2 times 3 times 3. And 75 is simply 3 times 5 times 5. And I've written them underneath each other for a reason. We're now going to draw something called a Venn diagram. Okay, so a Venn diagram ends up with two circles in this case, because we've got two sets of numbers. And what we do is we look at the top row and we look at the second row and ask ourselves, is there a number that's in the top row that's also in the bottom row? So I've got a 2, 2, 3, 3 on the top row, 3, 5, 5 on the bottom. So guess what? I've got a 3 and a 3 which match. So there's something in common. So I put that in the middle. Is there another number that's on the top, okay, that's also on the bottom? I've got a 2, 2 and a 3 left over. I'll highlight it for you. So I've got a 2, 2 and this 3 left over. And at the bottom, I've got a 5 and I've got a 5. So there's no other number that's on the top that's also on the bottom. So let's look at the top, the ones I've circled in yellow. What have I got left over? I have a 2 and a 3 left over. And the one on the bottom, I've got 2 5s left over. This one Venn diagram will now solve both questions for you. So whether they ask you for the highest common factor or the lowest common multiple, it does both for you. So let's see what we have to do to work it out. Now, the middle is probably the most important. This is called the intersection. This is where the two Venn diagrams meet. The intersection in the middle has the only number 3 in there. So the 3 represents the highest common factor. Simply known, anything in the middle that you multiply together, whether it's one number or more than one, is the highest common factor. In order to work out the lowest common multiple, because it's multiple, which means it's supposed to be a bigger number than 36 and 75, what we do is we take all the numbers on the left, all the numbers in the middle, and all the numbers on the right hand side. And what we do is we multiply the entire list out. So if I want to make it a bit more easy for you, I've got a 2, 2, 3, 3, 5. So if I rewrite it, there we go. So this is our Venn diagram that we've got. We said that the middle represents the highest common factor. This is what you should write in the exam, so it reminds you. And if we multiply everything inside the Venn diagram, that's including the middle. So we've got 2 times 2 times 3 times the middle 3 times 5 times 5, and we multiply this out. Therefore, it will give us the LCM of 36 and 75. If you're doing this without a calculator, nice and simple. 5 times 2 is 10. 5 times another 2 is 10. 3 times 3 is 9. 10 times 10 is 100. 100 times 9 gives me 900, which means if I go up in my 36 times table and my 75 times table, when will I get the lowest common multiple? Meaning, when will they both meet at the same number? They'll both meet when they hit 900. If I do another question just for you, so if I said to you, find the lowest common multiple and the highest common factor of 56 and 72, I can break the 56 down by saying 7 times 8 is 56, block off the 7. With 8, it's 2 times 4, block off the 2. And with the 4, it's 2 times 2 to make 4. I can use the 72 and say 9 times 8, neither are prime. 3 by 3, block it off. 8 becomes 2 by 4, block off the 2. And then I've got 2 by 2. It's quite a lot of numbers here actually. So what I'm going to do is, just to make it easy, I'm going to write them out so they're one underneath the other. So let's do the first one, the 56. I've got a 2. Look what I'm doing. I'm taking them off. So I've got 2, 2, 2. There we go. 3 lots of them. And I've got a 7. I'm then going to multiply out what I've got at the bottom. So I've got a 2 by another 2 lots of 2s. I've got a 3, and I've got another 3. So what do we do now? We draw a Venn diagram, use a different color. There we go. Make sure the intersection bit is quite big. And now we're going to start putting rings. I've got a 2 and a 2. Okay, so one on the top, one on the bottom, so it goes in the middle. I've got another 2 and a 2, so it can go in the middle. Good news, I've got another 2 and a 2, so that can go in the middle. So the ones I don't have that's in common, I've got a 7 on the top, so that'll be in the first ring. And I've got a 3 and a 3 in the other ring. That's left over. So again, if you remember carefully, the middle, I'll use red. There you go. The middle is the HCF. So it's not 2, 4, 6. It's 2 times 2 times 2. So 2 times 2 is 4 times another 2, which is equal to 8. So the HCF is equal to 8. You then have to work out the LCM. The LCM is probably one of the favorite ones people like. It's multiplying every single number that you see in the Venn diagram. So in order to do that, let me just write it out. I'll do it in red here, just because of space. So we've got I'll just do it here in a box. So we've got 7 times, now we know that 2 times 2 times 2 is equal to 8. Then we have a 3 times 3, and we have another 3. And if I multiply this out, I get 504, which means if I go up in my 56 times table and my 72 times table, they'll both hit 504. What does the highest common factor here, 8, mean? It means what is the highest number, the highest factor that can go into 56 and 72. It's easy to say 2 or 1, but that's the lowest, and we're not looking for the lowest. We will always look for the highest number. So 8 can go into 56, and 8 can go also into 72. Here's a worded question, or 2 worded questions that come up generally in the examination paper. It says a red light flashes every 28 seconds. So I'm just going to put here red light, and it flashes every 28 seconds. So 28, 56, 84, and so on. I can finish this off later. A green light flashes every 24 seconds. So 24, 48, 72, 96, 120. I can continue finishing the top one off. 112, 140, 168, 144, 168. What do you notice? Why have I stopped? Because I kept going up in the multiples of 28 and went up in the multiples of 24, and I found the lowest common multiple of those 2 numbers. Okay, this is the worded question, so I've done it this way. And the only reason why I've done it this way is because on a mark scheme, a lot of the mark schemes, they give you marks for actually writing out the 28 times table and the 24 times table until both numbers become the same. So therefore, the question is, after how many seconds will they both flash at the same time? It is after 168 seconds. You can also have a go at looking at question number 4. Try that yourself. Similar question. A bus heading to Belfast leaves Antrim every 36 minutes. A bus heading to Ballymena leaves Antrim at every 45 minutes. At 10 a.m, the bus to Belfast and a bus to Ballymena both leave Antrim bus station. Work out the next time. So it means I go up in my 36 times table and I go up in my 45 times table. So if I go up in my 36, I end up with 36, 72, 144. Sorry, apologies. I end up with, I don't know, 36, 72, 108, 144. I'll stop there. I'll do the 45 times. So 45, 90, 135, 180. Go back to the top. 180. I can stop now because after 180 minutes, we've noticed that the numbers are the same in the 36 times table and the 45. Therefore, 180 minutes is equal to 3 hours. So if a bus is at 10 a.m., when will both buses next leave at the same time? So 10 a.m. plus 3 hours, 180 minutes, which equals 1 p.m.